Now the minimum conductance in fused state is shown by minimum conductance in fused state. If we observe these all are second group anions: magnesium, calcium, barium, strontium. So if we move from top to bottom, the ionic nature is increasing. When ionic nature is increasing, automatically the ionization will also increases. So here they are asking minimum charge here through. Actually here instead of Ba, most of the books they are giving BeCl2. BeCl2 is a covalent compound, so it is in the top. So it will conduct least number of minimum conductance in their fused state. If you consider it as a barium, so here in fused state, as charge of the all are having +2 charge, but size is increasing. When size is increasing, mobility will decreases. So minimum charge can be through strontium. If it is beryllium will, because since it is a covalent compound, it will conduct minimum energy. If instead of beryllium, if barium is considered, strontium will be the size, its ionic size is more, so its mobility will be less, so it will conduct minimum electricity. Conductivity in units is directly proportional to area of the vessel and concentration of the solution, and inversely proportional the length of the vessel and then unit for the constant of the proportionality. Conductivity, let conductivity is denoted with G. G is directly proportional to area of the vessel and concentration of the solution. Area of the vessel and concentration of the solution, and inversely proportional to length of the vessel L, or then unit for constant proportionality. So G is equal to K into AC by L, or now they are asking K, units for K. K is equal to G into L by A into C. So conductance is measured in Siemens, length is measured in meters, and volume is measured in cross area is measured in meter square, and concentration moles per cubic meter. So moles per cubic meter, so we can reverse it. It will be written as Siemens meter into cubic meter by meter square into mole. So on simplification, m to the power 4, here m square, so resultant will be m square. So Siemens moles square per mole is the unit for proportionality constant K. Siemens mole square per mole. Second option is correct. The unit of specific conductivity. Specific conductivity means conductance C is directly proportional to area of the cross section and inversely proportional to length. conductance, or we can write it as C is equal to K into A by L. Now they are asking specific conductivity. Specific conductivity means if A is equal to 1 and L is equal to 1, then C is equal to K. So C is in Siemens or per ohm. Per ohm. So K is equal to C into L by A. That means per ohm, this is centimeter and this is centimeter square. So this is cancelled. So ohm per centimeter is unit for specific conductance. Per ohm per centimeter. That is fourth option is correct. The value of molar conductivity of HCl is greater than that of NaCl at a particular temperature because. So HCl molar conductivity, HCl is a strong electrolyte and NaCl is a strong electrolyte, they are completely ionized. So the molar conductivity of HCl is greater than NaCl because conductivity will depend upon the mobility of ions. Here the cation with smaller sizes will have more mobility. So here the cations, in both the cases anion is same, Cl minus, Cl minus. Cations in the case of HCl, cation is H plus, whereas in the case of NaCl, cation is Na plus. Na plus ion size is larger than H plus ions. So H plus ions are more mobile than Na plus ions. So mobility of H plus ions is more than the, so this is the reason. Now the unit for equivalent conductivity. Equivalent conductivity means equivalent conductivity is equal to K into 1000 by K into 1000 by N. So here the for K units are per ohm per centimeter. Per ohm per centimeter are the units for K. So per ohm per centimeter for K, for N is gram equivalents for cubic centimeter. So ohm per centimeter by gram equivalent for cubic centimeter. So on cancellation you will have per ohm centimeter square per gram equivalent. Per ohm centimeter square gram per gram equivalent, that is second option. The equivalent conductance of 1 N of electrolyte is nearly equal to equivalent conductance. Equivalent conductance means K into 1000 by N. Here the case 1 N solution, N is 1. Therefore K into 1000 by 1. 1000 means 10 cube. K into 10 cube. So 10 to the power 3 times more than specific conductance. K is specific conductance. So fourth option is correct. The highest electrical conductivity of the following aqueous solutions. Highest electrical conductivity. Electrical conductivity will depend upon number of ions present in it. The highest electrical conductivity of the following aqueous solutions. Highest electrical conductivity will depend upon number of ions. Here all are acetic acids and the substitutes of acetic acid, that means they are weak acids. But the ionization of acetic acid will depend upon several factors. Here if we observe, first one is CH3, all are same concentration, CH3 COOH. Second one is chloroacetic acid, CH2 COOH, chloro. Next, fluoroacetic acid, CH2 COOH, fluoro. And fourth one is difluoro, CH2 CH F. Now acetic acid will ionize as CH3 COO minus plus H plus. Then only it can conduct electricity. Now here, due to the presence of this chlorine, due to inductive effect, it pulls the electrons. So this will ionize more extent than acetic acid. Here in the case of chlorine and chlorine, fluorine has more electronegativity, so this is more ionizable. Since here two fluorine atoms are there, this is highly ionizable. So out of these four, this difluoroacetic acid will ionize in a large extent and it will have highest electrical conductivity. The conductance is directly proportional to area of the vessel and concentration of the solution, and it is inversely proportional to the length of the vessel. Then unit of constant for proportionality. So conductance is directly proportional to area of the vessel and concentration, inversely proportional to length. Then proportionality constant C is equal to K into A into C by L, or K is equal to C into L by A into C. So concentration is measured in, so this conductance is measured in Siemens and length is measured in meters, by area is measured in meter square, and concentration is measured in moles per cubic meter. Moles per cubic meter. Now this can be written as Siemens into moles into m cube by meter square into mole. So here m to the power 4, here m square, so we can write it as Siemens meter square per mole. Siemens meter square per mole. Second option is correct. If specific conductance and conductance of the solution is same, then cell constant is. So conductance is equal to specific conductance into cell constant. Conductance is equal to specific conductance into cell constants. Now here they are telling specific conductance are equal. So G and G star are equal when cell constant is 1. Specific conductivity of the solution increases with dilution, decreases with dilution, remains unchanged with dilution, depends upon the mass of the electrolyte. Specific conductance means the conductance that can be measured when 1 centimeter area and 1 meter length, 1 centimeter length. So when dilution takes place, what happens? If dilution takes place, number of the ions present in a given volume will decreases. That's why specific conductivity decreases with dilution. The solution of concentration C gram equivalent per liter has specific resistance R, the equivalent conductance of the solution. Equivalent conductance of a solution is equal to K into 1000 by N. K is specific conductance. Specific conductance K is inverse of its resistance, specific resistance R. So the specific resistance R. So when when K is equal to 1 by R, equivalent conductance will be 1 by R into 1000 by solution concentration is C. So this is 1000 by RC. Third option is correct. So in which case lambda value versus root concentration shows a straight line. So for strong electrolytes it is a straight line. For a strong electrolytes, so KCl is a strong electrolyte. So KCl, in the case of KCl, lambda versus root C is a straight line. Now the graph drawn between lambda equivalent values and the concentration of the electrolyte, which of the following electrolyte will correspond to the, so this graph is for weak electrolyte. Here the weak electrolyte is CH3 COOH. According to Kohlrausch law, the limiting value of molar conductivity of an electrolyte A to B ionizes as 2A plus B minus 2. It is dissociated like this, because naturally in any compound this is cation and this is anion. So dissociation will be like this. According to Kohlrausch law, the limiting molar conductivity will be equal to 2 into conductivity of A plus ions plus conductivity of B minus 2 ions. So 2A plus and B minus. This will be fourth option. Next, the equation representing the Kohlrausch law from this. Kohlrausch law means this is the conductivity of cation, this is the conductivity of anion. So molar conductivity will be the conductivities of both cation and anion. So it is based on number of ions also. So this is not correct. Second option is correct, because here V plus and V minus indicates the number of anions and number of cations on dissociation, because electrolyte was given. Since it is general equation, here we have to mention the number of ions also. Second option is correct. Next, expression showing the relationship between equivalent conductivity and molar conductivity. So equivalent conductivity and molar conductivity. Now molar conductivity is equal to K into 1000 by M, molarity. Equivalent conductivity is equal to K into 1000 by normality. So molarity by Z is equal to normality, or Z into normality is equal to molarity. So instead of this molarity, you can write 2 into normality, Z into normality. Instead of molarity, we can write Z into normality. So molarity is equal to Z into equivalent conductance. First option is correct. The ionic conductance of the following cations are given concentrations. The ionic conductance of the following cations in a given concentrations are in the order. So here all the cations, lithium, sodium, potassium, rubidium. So here as we move from top to bottom, cation size is increasing. When cation size is increasing, solvation decreases. When solvation decreases, conductance increases. So rubidium is greater than sodium, potassium, sodium. So first option is correct. Because lithium, due to its small size, it is highly solvated and it is least conductivity in their solutions. But in a fused state, the thing is different. In fused state, since there is no question of solvation, in such cases, rubidium will give least conductivity and lithium will give highest conductivity. The degree of dissociation of pure water alpha is equal to 1.9 into 10 to the power minus 9. Then molar conductivities of H plus and OH minus ions. So molar conductivity of, at infinite dilution, molar conductivity of H2O is equal to limiting molar conductivity of H plus ions and limiting molar conductivity of OH minus ions. So this will be 200 plus 350. This will be 550. This will be 550. So alpha is equal to molar conductivity limiting molar conductivity at infinite dilution. So alpha is equal to, therefore molar conductivity is equal to alpha into limiting molar conductivity. That means alpha is 1.9 into 10 to the power minus 9 into 550. One 1045. into 10 to the power minus 9. So it can be written as 1.04 1.045 into 10 to the power minus 6. Fourth option is correct. The molar conductivity values Ca plus and infinite dilution is respectively. So Ca plus 2 ions, (118.88) and Cl minus ions is 77.33 into 10 to the power minus 4. This is also 10 to the power minus 4. Now molar conductivity of CaCl2 according to Kohlrausch law, it is Ca plus 2 plus 2 into Cl minus. So Ca plus 2 is 118.88 plus 2 into Cl minus is 77.33 into 2, 154.66 into 10 to the power minus 4. So 118.88, 154.66, 14, 15, 13, 7, 273.54 into 10 to the power minus 4. Third option is correct. So CaCl2 conductivity of Ca plus 2 ions plus 2 into conductivity of Cl minus ions. Ca plus ions is 1.118 and Cl minus ions is this. So 118.88 in plus 2 into Cl minus ions, that is 154.66. The molar conductivity of NOAC and HCl are infinite dilution of water is 91 and 4 moles per respectively. To calculate additional value required. So here to calculate a weak electrolyte's molar conductivity at infinite dilution, we require, for example, CH3 COOH. This is a weak electrolyte. So to know the conductivity of this, we require strong electrolytes which are having a common ions. Here the ions are CH3, COO minus and H plus ions. So we need to calculate the limiting molar conductivity at its infinite dilution, because it's a weak electrolyte. We cannot measure the limiting molar conductivity of a weak electrolyte unless we know the limiting molar conductivities of anion and cation. Kohlrausch law states that if we know the limiting molar conductivities of these two ions, we can calculate the limiting molar conductivity of this. So we need an electrolyte, strong electrolytes which are having common ions. So strong electrolyte, acetate ion, the salt of acetic acid, CH3 COO Na and HCl. Both here we are bringing two different ions which are not present in this electrolyte. So in addition to these two, we require another strong electrolyte which contains the additional ions, that is NaCl. If we know the limiting molar conductivity of these electrolytes, by adding these two and subtracting this, you will get the electrolyte of this. That is Kohlrausch law. That means limiting molar conductivity of CH3 COOH is equal limiting molar conductivity of CH3 COO plus limiting molar conductivity of HCl minus limiting molar conductivity of NaCl. By that way, you will get the limiting molar conductivity of this, because here conductivity of CH3 COO minus plus conductivity of Na plus here from HCl you have H plus Cl minus, from NaCl you have Na plus Cl minus. So these two are minus. Minus so Na plus NaCl minus plus Cl minus Cl. The remaining ions are this one and this one, so that you will get the limiting molar conductivity of. So in the present question, we require cation and anion which are not present in it. So we require this Na and Cl. That is, first option is correct. The equivalent conductances of two strong electrolytes at infinite dilution in H2O, where ions move freely through a solution at 25 degrees centigrade, given below. The same question. Here two electrolytes were given, so we required another one which is not belong these two ions we required, so that is possible in this one, because this is strong electrolyte, we require another strong electrolyte which is having these two ions, cation and anion, Na and Cl, that is NaCl. The distance between two electrolytic cells is 2.5 centimeter and area of each electrode is 5 centimeter. That's Sun constant. So here distance L is equal to 2.5 centimeters and A is equal to 5 centimeters square. Then cell constant is equal to L by A, that is equal to 2.5 by 5, that is equal to 0.5. Ionic conductance of which of the following ion in fused state is low? Fused state means here lithium, sodium, potassium, cesium. Here low. So here if we move from top to bottom, size of the cation is increasing. When size of the cation is increasing, its mobility will decrease. So it will has least. If it is aqueous solution, solvation comes into the role. In such cases, cation with smaller size is highly solvated and least conductivity. Since it is a fused, there is no question of other solvation. That's why larger size cation will least conductance. The effect of temperature increases conductance as follows. The metallic conductance increases, electrolytic conductance decreases. The effect of temperature increases on conductance is as follows. Metallic conduction increases, metallic conduction decreases with increase of temperature. Electrolytic conduction increases, metallic conductance decreases. Yes, this is correct. Both metallic and electric conductance decrease. Wrong. Both metallic and electric decrease. So second option is correct. Next, effect of dilution on conductance is as follows. Effect of dilution. The specific conductance increases, molar conductance decreases. Specific conductance decreases, molar conductance increases. So here specific conductance decreases because specific conductance, the ions present in a given volume decreases, that's why specific conductance decreases. But in the case of molar conductance is equal to K into 1000 by molarity. So molarity is in the denominator. When dilution takes place, molarity will decreases, that means molar conductivity will increase. The correct equivalent conductance at infinite dilution, KCl, NaCl, because all are having same anions, Cl minus ions. So lithium, sodium, potassium. So K plus ions is larger in size, least solvated. So K plus ion has more conductivity than Na plus ion than Li plus ion. So KCl is greater than, second option is correct. Which of the following is not a conductor of electricity? So any substance can conduct electricity if it has free ions or free electrons. Here in this case, which of the following is not a conductor? Not a conductor. Solid NaCl, copper is a metal, it is a conductor. Fused NaCl is also a conductor. Brain solution is also a conductor. So non-conductor is solid NaCl